Okay, to understand why we might be interested in multiple variable linear models, let's start with a motivating example. Specifically, let's look at understanding glucose in diabetes patients. So, if you know anybody who has diabetes, you will know that they need to monitor their glucose level pretty continuously or frequently during the day. Now, a basic question for doctors in this field is to understand what causes glucose levels to rise and fall. We know there are many factors, and we understand what those factors are, at least qualitatively. For example, as I've shown here on the right, the y-axis is the blood glucose level, which changes with time, and there are obviously some events like eating food with high sugar levels that increases the blood glucose level. But what's difficult to do is come up with a quantitative model. That is a model that can numerically predict exactly how much the glucose level would rise given certain attributes of what the patient does during the day. Now, before we go and talk about trying to do that from machine learning, let's think about what you would do if you needed to try to develop such a model from first principles. In that case, you would need to have some analytic or mathematical model for the metabolism of sugar in the body. And any such model would probably be a simplification of what would actually occur, and anyway would probably have a number of parameters that are difficult to derive. For this reason, if you wanted to come up with a quantitative model, we can ask if machine learning would help. The data we're going to use for the diabetes example is from this AIM-94 project. This is an old data set. It's more than 25 years old now. So it's not medically interesting. There's a lot more recent data and a lot more that's been known from a medical standpoint. But this is one of the early, and what's important for us, simple data sets that's actually used in a lot of machine learning classes because it's easy to illustrate the key concepts. You can download this data set from a number of sources. In this case, I'm showing you one source, which is the University of California at Irvine Machine Learning Repository. This has a number of great data sets, and you might want to use one of these for your project. So in this case, this gives you a description of the attributes of the data set, and you can see, for example, here, if you scroll down, it shows you how the data was recorded. It was recorded in a sequence of events with some time and other attributes about that each event. To look at the diabetes data, I've created a very simple demo in the GitHub repository. You can find the GitHub repository at this address here. Once you go here, you can scroll down to Unit 3 on multiple linear regression, and here you'll see a couple of demos as well as the labs and problems. For now, we'll just look at the glucose, which is in demo 1. Once you click on this, the demo will load, and you can see the demo or the Jupyter Notebook. Now, there are two ways you can run this Jupyter Notebook. The first way is that you clone this entire repository to your local machine, and on your local machine, you install the correct software, namely Python and Jupyter Notebook, and then open up the Jupyter Notebook on your local machine. If you do this, you have to make sure you do all the installation correctly. Alternatively, you can run this completely in the cloud using a great facility called Google Colab. In this case, you don't need to install anything on your machine. You just need an internet connection. I'm going to show you how to do that now. Okay, let's see the demo on the Colab website. To do this, we first navigate to colab.research.google.com. this address here. When you do this, you should probably get a dialog box like this. If not, go to the File menu and select Open. On this dialog box, click GitHub, and then enter my GitHub repository, or the repository for this class. And that's at this address here, github.com/sdrangan. When you do this, you will select my repository, which is intro.yml, and scroll down to the demo we're interested in, which is Unit 3, Demo 1. After you click this, the demo should open. Okay, let's look at this demo. In the first cell we see here, we're going to just load two important modules. The first module, which is NumPy, is for all the basic mathematical and linear algebra operations. And matplotlib is for plotting. Remember that you can run any cell by either pressing the arrow on that to the left of that cell or hitting Shift-Enter. The first time you run the cell, it might give you a warning. That's fine, you can trust this notebook. The first cell might take a little time to load, but it'll finish. And spinning here. Okay, we've run that first cell. The next part is to load the diabetes dataset. To do this, we're going to load the sklearn module, which stands for scikit-learn. And that's one of the basic machine learning packages in Python that has a lot of powerful tools. Since the diabetes dataset is so widely used in machine learning classes, it's actually included in one of the modules, the datasets module. So all you need to do to load the diabetes dataset is run this command here. This will create an object, diabetes, and in this object there will be two arrays, the data and the target, that I'll explain momentarily. Let's run that cell. All right, the data is loaded. Before we go on, actually the diabetes data has a nice description, which is also included. And if you print that description, you get this. It tells you here that there's a number of variables or attributes, and they're described here. And it also shows you that there's a target here. It also gives you the source URL for that data, the one where it originally came from, and this reference to this excellent paper, which was one of the earlier papers that studied this data set from a statistical standpoint. You'll recognize several of the authors on this paper because they're the authors of the textbook we'll be using in this class. All right, let's go on a little further. As I mentioned, there's two objects that are loaded from the data set. The first is the set of attributes, or the data matrix, which is X. And this is simply a 442 by 10 matrix. The reason is that there are 442 patients in this data, or samples. So and each sample is one row in this array. And there are 10 attributes that we've mentioned, and each attribute is one column. And I've just printed the size as shown here. You can also print the size of the target variables. Let's do that as follows. And you can see that this is 442. There's one target for each sample, and that real value number is the glucose level that we want to predict. Okay, now that you've loaded the data, let's look at the problem a little bit more mathematically. What we have for each sample are 10 attributes, like the age, the sex, the BMI, and so on. Since there are 10 of them, we could label them as x1 to x10. And what we want to do is take that vector of values and make a prediction of the glucose level. If we label the glucose level as y and a prediction y hat, we want to find a function that maps the x's to that y. The problem is here that the function has to take account of multiple variables, and there's a large number of such functions that are possible. Indeed, this is what you would call a multivariable function. Multiple linear regression that we're going to look at momentarily is one simple such class of functions. Before we do that, let's also look at the data we have to try to find that function. We saw that there were two objects, the x, which is the matrix of the attributes. In this matrix, that there are n samples, or one sample per row, and there are k attributes, in our case 10, one attribute per column. We also have a vector of the target values. In this case, each column would be, each element yi would be one value of glucose, and each row would be one sample with the 10 attributes for that sample, like the age, the BMI, and so on. Now, before you go on any further, I've provided a few little in-class simple exercises that you should do by yourself before you go on. The first two are just practicing indexing in the arrays, and the second one was just visualizing the data, at least one variable at a time, so you can get an idea of what the data looks like.